This is JSteele's Precalculus section 9.2. We're going to be dealing with systems of linear equations in two variables. So as you can recall from Algebra 1 and 2, for a system of linear equations in two variables, exactly one of the following is true. The number of solutions is either 1, 0, or infinite, and we can determine that based off of substitution, elimination, or graphing. The graph of the system with one solution is just a pair of intersecting lines. So if we have a coordinate grid, two of our lines could just look like this, and the intersection right here would be the solution. The type of solution is consistent and independent. For a graph with 0 solutions, it's just a pair of parallel lines. So we'd have a graph with two lines that were parallel and they would never touch. This type of system is inconsistent. Then if we have an infinite number of solutions, these two lines are the exact same line. So they would literally just be two lines drawn directly on top of each other. And this type of system is consistent and dependent. So taking a look at some examples, it says solve the system algebraically, either using substitution or elimination. So number 1, we have x equals 4 minus y, and negative x plus y equals 0. Since we already have one of our equations in the form x equals something, let's take this 4 minus y and we will plug it in for the x. So now we have negative 4 minus y plus y equals 0. Distributing out this negative, we have negative 4 plus y equals 0. So since we have two y's, we have negative 4 plus 2y equals 0. And then solving for y's, add the 4 to each side. So we have 2y equals positive 4. And then divide the 2. So y equals 2. Now, when y equals 2, we need to determine the x value. So we will use the first equation. So we'll say x equals 4 minus y, which is 2. So x equals 4 minus 2. Since 4 minus 2 is 2, we have x equals 2. So this ordered pair is 2, 2. So we know there is one solution. And the lines are intersecting. So we can say one solution, intersecting lines. For number 2, we have 6x plus 4y equals 12 and 9x plus 6y equals 18. If we were to multiply the first equation by 3, and multiply the second equation by negative 2, we end up with 18x plus 12y equals 36. And we have negative 18x minus 12y equals negative 36. When adding these two, we're left with 0x plus 0y equals 0, since 0 equals 0. Notice you see the note, it says note special result, and that is because anytime we end up with 0 equals 0, we can ask ourselves, is that statement true? Since yes, that statement is true, we know that there are infinitely many solutions. So we can write infinite solutions, which means the line is the same. So we can write infinite solution, the same line. And now looking at our third example, we have 2x plus y equals 7 and y equals 4 minus 2x. Since we already have y equals something, we can take that 4 minus 2x and substitute it in for the y in the first equation. Then we have 2x plus 4 minus 2x equals 7. 2x minus 2x cancel out and equals 0, so we have 4 equals 7. So now you ask yourselves, is that statement true? Since that statement is not true, we know that there is no solution. So our answer is no solution, which means that the two lines are parallel. So we can write no solution and parallel lines. The next example says, use a system of linear equations to solve each of the following. Number 1, the sum of two numbers is twice their difference, and the larger number is 6 more than the smaller number. Find the two numbers. So let's just let's write down what our variables are. So if we have x and y, we'll say x equals the larger number and y equals the smaller number. We just need to define our variables. And the sentence that says the sum of two numbers is twice their difference. This tells us that the sum of the two numbers, so the sum of the larger number and the smaller number, so x plus y, is twice their difference. So 2 times their difference, and difference is just having x minus y. Since x is the larger number, we're going to put the larger number and subtract off the smaller number, which is why it goes x minus y instead of y minus x. And then the statement, the larger number is 6 more than the smaller number. This tells us that the larger number, which is x, we're going to have x equals 6 more than the smaller number, so x equals y plus 6. So these are our the two equations that we will be using. Since we already have x equals something, let's use the substitution method. What we're going to do is plug in that y plus 6 in for both of the x's in the first equation. So we'll have y plus 6 plus y equals 2 times y plus 6 minus y. Since on the left-hand side, since we have y plus y, we have a total of 2y. So we have 2y plus 6 on the left-hand side. And looking at what's in parentheses, we have y minus y. So those two y's will cancel out, and we are just left with 6. So 2 times 6 equals 12. So on the right-hand side, we have 12. So since we have 2y plus 6 equals 12, now it's just basic algebra. Subtract the 6 over, and we have 2y equals 6. Divide the 2, so y equals 3. So now that you have y equals a number, we're going to take that and plug it into that first equation, the x equals y plus 6. So when y equals 3, we can find our x value. We have x equals 3 plus 6. Certainly 3 plus 6 equals 9, so x equals 9. So the coordinate of our answer is just 9, 3, which is just one solution. And since we have one solution, that tells us our two lines are intersecting. So intersecting lines. For our last example, It says the admissions to an amusement park is $1.50 for children and $4 for adults. On a certain date, 2,200 people entered the park, and the admission fees collected totaled $5,050. How many children and adults were admitted? So first we need to define our variables. So you can say x equals the number of child tickets, and we'll say y equals the number of adult tickets. So since we're dealing with people and we're dealing with money, we're going to have an equation for money, and we'll have an equation for people, so the number equation. So the dollar equation, if we know it's $1.50 for child tickets and $4 for adult tickets, and that totaled to $5,050. Our first equation is 1.5x plus 4y equals 5,050. The equation for the number of people, we just add children plus adults, we get a total of 2,200 people. So to solve for one of our variables, it would be the easiest just to multiply the second equation by -4. So we'll have 1.5x plus 4y equals 5,050. And we have x plus y equals 2,200. You can do this many ways, but one of the ways I'm just going to take the bottom equation and multiply it by -4. So our top equation will stay the same. We'll still have 1.5x plus 4y equals 5,050. But our bottom equation will become -4x minus 4y equals -8,800. Now just adding these two, we are left with -2.5x equals -3,750. Solve for x, we need to divide by -2.5. So then we have x equals 1,500. So we know that there are 1,500 child tickets. So now to solve for the number of adults, we can just take the x equals 1,500 child tickets and plug it into one of our equations. I think it's the easiest to plug in for the x plus y equals 2,200. So then we have 1,500 plus y equals 2,200. Subtracting off 1,500, we are left with y equals 700 adults. So in total, we have 1,500 children and 700 adult tickets. So the ordered pair would be 1,500, 700. So that would be the ordered pair. The homework that the work we'll be working on in class is on page 649, and it is numbers 1 through 33, every other odd, and it is also 43 through 53 odd.